We want to see at what interval f is increasing. We have f prime of x is less than 0 if x is greater than 3, or x is between -6 and -2, and f is positive if x is less than -6, or x is between -2 and 3. Let's look at the number line here. We want to plug in values. So we see the numbers that we have are 3, -6, and -2. So those are the numbers that we're going to plot in here. Now we just have to test the different regions. So let's say when x is less than -6, that's going to be over here. The derivative is positive. Between -6 and -2, that's negative. Between -2 and 3, that's over here. That's positive. Greater than 3 is negative. So the function is increasing when we are at -infinity to -6, and then -2 to 3. So make sure not to include -6, -2, and 3 because the derivative there is 0. Now we want to see what intervals is the graph of f concave downward. And we're given that the second derivative is negative if x is less than -6, x between -3 and -2, x between -2 and 1, and x being greater than 4. And it's positive if x is between -7 and -6, -6 and -3, 1 and 3, then 3 to 4. So let's draw the second derivative number line. And for this, we're going to include the values that we see here. So looks like we have -7. The next one is -6. Then -3. After -3, we see we have a -2 here. And then a 1, 3, and a 4. Okay, so let's see what's happening when x is less than -7. That's over here, we're negative. When x is between -7 and -6, that's over here, that's positive. -6 and -3. It's down here, that's positive. -3 and -2. That's up here, that's negative. -2 and -1. That's also negative. 1 to 3 is positive. Also 3 to 4 is positive. And if x is greater than 4, we have negative. So the question is asking what intervals is the graph of f concave downward. That's when the derivative, the second derivative is negative. So it's from -infinity to -7. -3 to -2. So here you want to split up -3 to 1 as two separate because the second derivative at -3, -2, and 1 is 0. And then we go from 4 to infinity. That's our answer. Finally, we want to sketch a graph of f. Now this one's a bit tricky because you want to take advantage of the first derivative and the second derivative number line. So what we could do is, I think the easiest way to do this is to combine both of these. So let's first see, okay, what values don't they have in common? What points don't they have in common? So this has a -6, a -2, and a 3, which are all the points over here. So I could just take advantage of using these points and then plug in, okay, when the derivative is positive, when it's the second derivative is negative, etc. So let's just copy down the values from the second derivative. Okay, so when x is less than -7, we'll just copy what we have here first. So concave down, etc. All right, then we'll go back up here. So the first derivative is positive when x is less than negative 6. So it's increasing. To the between negative 6 and negative 2, it's decreasing. And then from negative 2 to 3, it's increasing. After 3, it's decreasing. Okay, so now we have this. We can start graphing. So we'll start at negative 7. Actually, let's try this again. We need a bigger graph. So let's center it over here. So we'll start off with negative 7, negative 6, negative 3, negative 2, and then 1, 3, and then 4. So this is not going to be drawn to scale, and we don't know the values of y unless we plug it into, we don't have f of x, so we can't figure out the values of y. So we just need to get roughly the picture here. So let's see, from negative infinity, we're increasing in concave down. So increasing in concave down. From negative 7 to negative 6, we're still going to be increasing, but we're going to be concave up. Something like this. And at negative 6, we have a maximum because it changes from increasing to decreasing. So that's going to be a maximum, and then it's going to be concave up. So what this looks like actually is a cusp, because you concave up and then concave up like this. So something like that. And then between negative 6 and negative 3, it's decreasing and concave up. And then it switches to concave down. So let's try that again. Concave down, decreasing to negative 2. And then at negative 2, it's still concave down, but it's increasing now. So all the way up to 1. And then at 1, it's going to be increasing and concave up to 3. 3 to 4, it's concave up still, but it's decreasing. Something like that. And then after 4, it's decreasing and it's concave down. Now we should be careful and see where we have points of inflection, or points where the concavity is 0. At negative 7, the concavity here is 0 because it's like a straight line. And then, let's see, negative 6, the concavity is 0. Yeah, that works. Or undefined. It could be either one. Negative 3, same thing. Looks like it's 0 there. And negative 2, that changed concavity. That's undefined. And then 1 changes concavity. That's supposed to be like a straight line. And then at 3, it's supposed to change concavity here. So it's like a cusp. And then F4 also changes concavity. So this is our graph for f of x.